Okay, so point A moves up and down. Okay, what about point B? What does it do? Makes it wider. It also reflects it, right? Point B reflected it and made it wider or narrower. The words that you're going to use for that are stretch and shrink. Stretch and shrink. Okay, so it makes it skinnier or it makes it wider. On slide 2, one kind of transformation we're going to explore is called translation. If we translated it 2 units down, which graph would it look like? If we took the exact same graph and moved it 2 units down, what would it look like? Okay, so some of y'all are saying top right or bottom right. I'd probably say top right, just because it literally looks like it moved down. But I would probably need a little bit of a bigger picture. All right, looking at slide number 3, click the above to see what happened. So for each one of these equations, what's going on? Say it again. Yeah. So the second one is going down. So we're going from black to gray, or I'm sorry, gray to blue. So the first one we're moving up 3 units, and the second one we're moving down 4 units. Does everybody see where that's at? First one we're moving up 3 units, second one we're moving down 4 units. Okay. Slide 4, I want you to write the equation for this one. We're writing the equation. From this number, so from 4 to 9, what are we doing? Adding. And then from 1 to 6? Okay, so what are we doing? What are we writing that equation as? X squared plus 5. So when we write this expression, we're going to say x squared plus 5. All right, so look at the parabola. When we change this, what's happening? When it's negative, where is it facing, up or down? Down. When it's positive, where is it facing? Up. And as we get higher on that number, it's getting skinnier, right? So in this, how is the transform parabola like y equals x squared? And then how is it different? Go ahead and take a moment. Tell me what's similar, what's different about the transform parabola. So on slide 6, it says some of these equations represent the parabolas in the graph. Select the one that does not. There might be more than one answer. Some of these graphs represent the parabolas in this graph. Select the one that does not. Okay, some of y'all are saying y equals negative x squared. Why is that? So some of y'all are picking this one. Why? Because none of them are facing down. Good. What about this one? So x squared plus 1, that would be up, right? So this would be the graph right here. It would look like this. And that's 9 of those, right? So there's not one with a shift up of 1. The next slide, we say that this is called a vertical stretch, okay? So from 4 to 8, what happened? How do we get from 4 to 8? We can add 4 or multiply by 2. From 1 to 2, what do we do? Multiply by 2, right? So from here to here, we're actually having this equation. We're having y equals 2x squared. Go ahead and do slide number 8. Tell me what is going on in that equation. All right, so some of y'all are saying it's getting multiplied by 5. Some of y'all are saying that there's a shift up. So there's a stretch of 5. It goes up by 1, and it's going to be reflected across the x-axis. So it's going to be facing down, if you want to say that. All right, go ahead and try slide number 9. There's a bunch of different challenges on here, so yours might be different from the one that I had. So go to slide number 9. Once you get a check mark on number 9, you can go to slide 10. If this is my equation, or if this is my table and I want to write the equation, first I'm going to say y equals x squared, okay? And then I'm going to say from here to here, what did I multiply by? 2. So there's going to be a 2 out front. And then from here to here, what am I adding by? So this will be 2x squared plus 3. Ta-da! What's happening? So again, you're telling me what's the transformation that's happening on this one. All right, so on slide 11, some of y'all were saying that it has we're going to call this a shrink, not a stretch. Stretch is greater than 1. A shrink is less than 1 of 1/2. And then it's going to reflect across the x-axis. And then we're going to move up 3. Reflect across the x-axis, shrink by 1/2, and then up 3. Now on slide 12, it's a little tricky. You kind of have to pay attention to like where the values are, like what are the x-intercepts and that kind of stuff. And those are going to be decimals, so it's going to give you a little bit of trouble. But this would be up at 5. It would be facing downwards. And we want it to cross the x-axis at negative 1.58. And the other one is positive 1.58. So it's going to look something like this. You might have to like adjust the width of the parabola just a little bit. But if you can get the fact that it's facing downwards and it crosses at 5, that's okay. I would take this and I would go into Desmos and graph it and then use the table to help me plot points. So like I would go into Desmos. You won't need it for the mastery check, but on the test, yes. And then if I pull up the table on this, you see how it crosses at like 1.58. So that's going to give you a little bit of a weird answer. But here's another point that you can plot, 1,3 and negative 1,3. So it should pass through those points to get it a little bit more exact. Go ahead and go to the next lesson. So that's going to be called vertex form. Go ahead and go to the next lesson. It's going to be called vertex form. And then go ahead and try those 2 slides. Why? What did you come up with? Okay, so if I plug in a negative, all right, conversation stopping. All right, if I plug in a negative integer, what would I get? Give me a negative integer. All right, -1 first. All right, so if I plug in -1 into this equation, I would get -1 minus 3 squared plus 1. -1 minus 3 is -4. -4 squared is 16. 16 plus 1 is 17. Is 17 less than 1? No, so 1 is our minimum. Oh, I'm sorry. Yes, 1 is our minimum. It's the lowest that it can go. Do you see how in the table it's got 5 here and then it goes down to 1 and then it goes back up to 5? That's representing that little like swoop. Okay, so 1 is our minimum. It's our vertex, that location. All right, see if you can find the minimum value. Take a moment. So what'd you plug in first? Okay, so somebody plugged in 1. Okay, when they did that, oop, come on. The Y value, 30, put them up. The Y value is 33. What other X value could you plug in to get less than 33? Okay, let's try negative 3. If I plug in negative 3, I'd get 1. Can you get something lower? What about negative 5? I got negative 3. So this is my lowest Y value, which means that this is the minimum. And the vertex would be negative 5, negative 3. So you notice how in this equation, those numbers come up. So it's the opposite sign of this, and then this number.
Wait, what?
So it's the opposite sign of this, and then it's the this number out here. Okay, the equation that you'll see this written like is this. To pull out the vertex from this, you would just change the sign for the X and then keep the Y. We're going to see that on the next slide. So slide number 4. This is how they determine the minimum value. Can you explain the strategy to determine the minimum value? Okay, so they wanted to make this part equal to 0. So what number would I need to plug in order to make it equal to 0? For this equation? 4. So I would plug in 4. This would give me 4 minus 4 squared plus 7. 4 minus 4 is 0. 0 squared is still 0. 0 plus 7 gives me 7. This would be my minimum value. The reason why I know that is because the vertex would have been 4, 7, and that would be the minimum. On number 5, discuss with a partner where you see the vertex in this table and in the equation. So take a moment, talk to your neighbor. Okay, so again, you could see this in the table because you're looking for the lowest Y value, or you can pull it from the equation and it's the opposite of what's in this little parentheses, and then negative 3. Okay?
So that one is the vertex, right?
That would be the vertex. On slide 6, I want you to write this vertex in vertex form. So this is how this equation looks, and here's the vertex. So if I give you the vertex, can you write out the equation? If you're changing this, use this vertex. Take a moment. So if you wrote this, you should have gotten x minus 3 and then minus 4. So we changed the sign of 3 and then plugged in negative 4. Okay. Slide number 7. What do you notice that's similar and what do you notice that's different from each one of these equations? All the vertex is the same. What is different? The stretch or the shrink, right? Okay, and whether or not it's reflected. All right, go ahead and write an equation with this vertex. So you should have gotten x plus 6 squared minus 2. And you could have put whatever number out front, or you could have made it negative. That's completely up to you. Slide 9 is going to be different for each person, but find the vertex given that equation. I want you to check your work and then go to slide 10 and 12. You can skip 11. So do slide 9 and then go to 10 and 11. Need it? If I were to take this equation, yours is going to be different. But if I were to find the vertex, I would change the sign of this guy. So it would give me 4 and then keep the sign of the next guy. That would be 3. So the vertex would be 4, 3. Okay. On slide 10, says which one does not represent this? Okay, pay attention because my last class was struggling with this. First of all, if I wrote this in vertex form, the vertex is 5, 4. I would have x minus 5 squared plus 4. And it's facing downwards. So this one would work. That's this guy. If I wanted to write this in intercept form, this is what we learn on Monday and Friday. Okay. Intercept form is where it crosses the x-axis. So we got 3 and 7. I'm going to switch the sign of those and plug an x out in front of it. And remember, it's negative. So this guy is also correct. Okay. This one right here is incorrect. If we graph this, this would not cross at any x-intercept and would not have that same vertex. Yeah, but this third one definitely is going to be wrong. This one right here, they didn't do the right vertex, so that was incorrect. I don't know why they put that as the right answer. Okay. On slide 12, go ahead and determine the vertex, and then tell me. We're going to talk about the transformation. So go ahead and tell me the vertex on this one. What's the vertex? -1, -5. Because remember, we keep the second one, we change the first one. What are the transformations? So what's going on here? We have a stretch of 3, a horizontal shift, so that's going to be left or right. So let's say we go left 1, and then we're down 5. The way you can see this is if you graphed it, it would have that shape. It would be to the left 1, stretch 3, and then down 5. Yes, the vertex is -1, -5. Yeah. Yeah, give it a pass. Okay. Three times x minus 5. Is that the right equation? I think so. Okay. So notice how my vertex is here. If it wasn't a stretch, then this would be the original function. Do you see how it's pulled up a little bit more on that blue one? That's a stretch. Yeah. It's kind of like when you were little and like you put your arms up for somebody to pick you up, it would pull your arms up like this. Great. Stretch. Fraction. Yeah. Okay. The only thing that I don't want you to get tripped up on is if I give you this in intercept form like this, and I said, hey, what's the x-intercepts? Remember, you have to set that equal to 0 and solve. So it would give me x-intercepts at 7 and 3, right? Okay. If I were to say, find the vertex given this, you would find the middle number between 3 and 7. With me? Okay, so 3 to 7. What number is in the middle? 5. That's going to be your axis of symmetry. With me? Axis of symmetry has the x value for the vertex. So in order to find the y, you're going to take x and plug it in. I'm getting some blank stares. A little concerning. Okay, so axis of symmetry, once you find that, you're going to plug it back into the equation to find the y value for the vertex. Okay? Question? Go ahead. Intercept is this guy?
Oh, yeah.
Okay, so if it was in vertex form, the axis of symmetry is the opposite sign of this. That would be x equals -1. Yeah. That one's a little easier. Okay. Question. So it's transformations, and then it's talking about vertex and x-intercepts. Yes. Yeah. Okay.